Hello everyone, my name is Neil Jackson, and this is Lab 1 entitled Charged Tapes for Physics 2212. So Lab 1 tasked us with creating a few pieces of charged U-tapes in order to see how they reacted with each other and the environment. To create such tapes, we stuck two pieces of tape together and we ripped them apart really quickly. And this had the effect of separating the charges among the two pieces of tape. So we want to do this lab because it gives us a very good understanding of how much excess charge can be made and found on common household objects, and it also is a great way for us to use these three fundamental physics principles: the gravitational force, electric force, and electric field formulas. Once I have made the U-tapes, I made a quick little hypothesis as to what would happen if two U-tapes were brought together, and I have a video right here recording it. I hypothesized that the two U-tapes would repel each other, and that came true. And this tells us that both U-tapes must be um, either both positively charged or both negatively charged as they're repelling each other. And then when we bring the same U-tape next to a book, otherwise known as a neutrally charged object, we can see that the U-tape is also attracted to the neutrally charged object. At first, this was pretty confusing, but after this week of lecture, I discovered it's because the U-tape is actually polarizing the book. Very cool stuff. And this is just a video of the U-tape being attracted to my hand, which is the general test we use just to make sure that the U-tape was working properly. Now the main part of the lab starts to kick in, where we are tasked with finding the charge on one of these U-tapes. And this can be achieved by setting up the following experiment, where we balance one U-tape on top of each other, and when both U-tapes are stable, the system reaches static equilibrium, meaning we can set the gravitational and electric force equal to 0 and solve for our charge. Here's my glow script code. The code matches very closely to lab 0, and when I run it, I get this with my printed values down below. And as you can see, this top proton represents the tape 2. And as you can see, the two arrows are equal, thereby indicating the object is in static equilibrium. Observing the free body diagram of the floating tape allows us to realize that the force of gravity should be equal and opposite to the electric force. We can also assume that each tape has the same net charge because they were made the same way, and we can treat each tape as a point charge because that simplifies the math a lot. So just a quick calculation of the mass at first, and then we're able to set the electric force equal to gravity, and then algebraically walk through and solve for QB, which I got to be a positive 5.8 times 10 to the negative 8 coulombs. With the charge of a U-tape in hand, we're able to calculate the number of electrons on a U-tape by comparing the excess charge to the singular charge of an electron, and I wound up getting this negative number, which means that there's an electron deficit on the tape. Using this formula, comparing the surface area of the tape to an atom, we are able to calculate the number of atoms on tape B. And then finally, by comparing these two numbers, we're able to get a ratio of 0.0003356% of atoms lost electrons when ripping apart the U-tape from the base tape. For the what if question, what if protons were negatively charged and electrons were positively charged, I said that the results should remain the same for our lab. This is because, as we saw earlier, the two U-tapes repelled each other when they were close to each other. Meaning, if the sign of their charge was flipped, then we should still see that they repel each other, as like charges repel and different charges attract. That's just how physics works. For our why question, I said it's important to handle the charged tapes as little as possible because once that tape is touched, it's going to begin to return to a neutral state. And this is because whenever, for instance, your hand were to touch that tape, electrons would either flow from your hand to the tape or from the tape to your hand to once again put the tape in a state of equilibrium. And finally, we have a results and error page where I have listed the charge of the U-tape, electron deficit, and how many atoms approximately lost electrons. And I have listed the gravitational and electric force. Now these values should be the same, and I have some errors listed below that are probably why they're not. And it's just due to human error, which is just measuring values and making the tapes, and then probably some calculation errors because of the assumptions we made in the lab. Thank you.